Okay, today we're going to go over 8-2 special right triangles. Go ahead and write that down. The objective that we're going to cover today is to use the properties of a 45, 45, 90, and a 30, 60, 90 triangle. So go ahead and write that down. 45, 45, 90, 30, 60, 90. Okay, let's take a look at this next theorem. Theorem 8-5. You have a 45, 45, 90 triangle. What is this theorem trying to say? When you have a 45, 45, 90 triangle, both legs are congruent, which means they're the same. So you have leg over here and leg over here, S, both congruent. And the hypotenuse, which is this guy right there, S square root of 2, is the square root of 2 times the length of the leg. So here are my legs. Here is my hypotenuse. So the hypotenuse equals the square root of 2 times the leg. Let's take a look at problem 1. We want to find the length of the hypotenuse. Using the theorem we just went over, if we have this triangle where they give us side is 9, and they want us to find what is the hypotenuse. What kind of triangle are we given? We're given a 90, 45, 45, or 45, 45, 90 triangle. How do we find out what the hypotenuse is? We take the hypotenuse, we know that it's the square root of 2 times the leg. So we take our hypotenuse, which is an h, which we know it's square root of 2. We know that the leg is 9. So our hypotenuse for this triangle would be 9 square root 2. Because we have a 45, 45, 90 triangle, we know the hypotenuse is the square root of 2 times the leg. We put those two together and find out what the hypotenuse is. Okay, if we take a look at example B, we have another 45, 45, 90 triangle. My hypotenuse is x, but my side, or my leg of this triangle, is 2 square root 2. So how do I use this information to find out what the hypotenuse is? I take the information from the theorem, knowing that the hypotenuse, the leg, is the square root of 2 times the leg, which in this case is 2 square root 2. So I'm going to take the hypotenuse, which I know is square root of 2, and I'm going to multiply it with the leg, or the side, which is 2 square root 2. When I do that, I end up getting 4. Remembering that when I multiply square roots, I have square root 2 times another square root 2. That means my answer would be square root 4. And what's the square root of 4? 2. So then I have to take 2 times the 2 on the outside of there, and that would give me 4 as my answer. Okay, let's take a look at this problem 2. Find the length of a leg. Again, given a 45, 45, 90 triangle, my hypotenuse is 6, and my leg is x. We want to find the value of x. What do we do with this problem? We know that the hypotenuse is the square root of 2 times my leg. So what I need to do is insert those numbers where they belong. 6 is my hypotenuse. Come over here for my triangle. That's going to equal the square root of 2 times x. Now I want to get x by itself, so what do we do here? I can circle and draw my wall. Let me rewrite it over here for you. So now we have 6 equals the square root times x. I want to get the x by itself, so I'm going to circle my x, draw my wall, which means I have to divide both sides by the square root of 2. By doing that, that cancels out, and I'm left with 6 over the square root of 2 equals x, which brings me to that step there. Now, we know when we want to solve for x, and we have a square root of 2 down here in the denominator, we need to get rid of that square root sign. In order to do that, we need to multiply the top and the bottom by the same number of the bottom number, which is square root 2. So we multiply square root 2 on top and on the bottom. So when we take square root 2 times 6, we get 6 square root 2. And when we multiply square root 2 times square root 2, we get 2. Knowing the trick that if we multiply the square root by the same number, all you're doing is removing the square root sign. So you have 2 square root 2, so you have a pair. That ends up being 2. So now you're left with 6 square root 2 over 2, and you have to reduce those two numbers, looking at it as a fraction. If you look at it over here, we have 6 over 2. How do I reduce 6 over 2? That would equal 3. So 6 over 2 reduced is 3, and I'm left with square root of 2. So I have to remember to reduce my fractions to get my final answer. Okay, let's take a look at problem number 3. Finding the distance. You're probably thinking, when am I ever going to use this formula to mean anything? Well, let me tell you when. If you're looking at a softball field and a high school softball diamond, it's a square. The distance from base to base is 60 feet. I'm underlining my key facts, 60 feet, which goes with the 60 in that picture to the side. So the nearest foot, how far does a catcher throw the ball from home plate to second base? Now we're going to use our 45, 45, 90 triangle theorem to solve this problem. The distance D is the length of the hypotenuse of your 45, 45, 90 triangle located over here on the side. To do that, we know that the side is 60 and the hypotenuse is the square root of 2. So my distance would be 60 square root 2, where the hypotenuse is the square root of 2 times the length. So if you put that in your calculator, 60 times the square root of 2, you'll get 84.85, etc. Rounding that, the distance would be 85 feet. So there, that's when you're going to use this 45, 45, 90 theorem.